Welcome to The Explainer. When it comes to engineering a breakthrough, people often assume it requires a random flash of absolute genius. But true innovation is a highly repeatable architectural discipline. I'm the navigator, your idea mechanic. My job is to take abstract theories and translate them into practical execution right here in the lab. Think back to the last time you saw a construction crew try to force a massive concrete pile into the ground. Or maybe you've struggled yourself to cut through a stubborn object using pure continuous pushing. You fall straight into the brute force trap. You assume that to overcome physical resistance, you need to build a bigger hammer or push a little harder. That usually results in cracked materials, broken tools, and an exhausted crew. If you want to stop fighting friction and start engineering past it, hit that subscribe button and ring the notification bell to officially join our Idea Mechanics team. Drop your current technical challenges in the comments below, because today we are breaking down a framework built to solve those exact bottlenecks. We are applying TRIZ Principle 18, mechanical vibration. Its objective is simple: stop fighting resistance with continuous static force. Step 1 requires us to identify the exact friction point, isolating where our continuous push fails to overcome the material's resistance. That brings us to step 2. Introduce oscillation. Instead of applying a steady push, we introduce a rapid back and forth movement. This instantly shatters the static friction lock. You see this in consumer goods all the time. Engineers looked at the exhausting continuous downward force required to slice tough food and replaced it with rapid blade oscillation. The vibrating carving knife does the work for you, easily slicing through material. The exact same logic applies to electric toothbrushes. By building rapid oscillation directly into the brush head, engineers removed the intense human effort required for daily manual scrubbing tasks. Scaling this up to industrial applications, traditional impact hammers drive piles by smashing them repeatedly, which is slow and highly destructive. Modern vibratory hammers replace those blows with rotating eccentric weights that generate intense, high-speed vibrations. This oscillation transmits directly into the ground, temporarily liquefying the surrounding soil. Bypassing physical resistance by altering the environment is vastly more efficient than trying to overpower it. Sometimes basic shaking isn't enough. That's when we move to step 3, elevate and resonate. We take the vibration and scale the frequency up. By pushing the vibration beyond human hearing, we enter the ultrasonic frequency range, which allows us to manipulate materials at a microscopic level. In ultrasonic cleaning, these high-frequency sound waves travel through a liquid solution to create intense microscopic cavitation bubbles. As these bubbles rapidly form and collapse, they scrub away dirt and grease from intricate surgical instruments and electronic parts without causing any mechanical wear. We can also leverage resonance. Every physical object has a natural frequency. When you match your applied oscillation to that exact natural frequency, you get an enormous impact with very little energy input. In medicine, doctors use a procedure called lithotripsy to treat kidney stones. They tune sound waves to match the exact frequency of the stone, vibrating it until it shatters into harmless fragments, while leaving all the surrounding soft tissue entirely intact. Civil engineers rely on the same principle to build durable structures. When pouring concrete, trapped air bubbles create voids that weaken the final product. Inserting a resonant vibrator into the wet concrete forces those air bubbles to the surface, allowing the aggregate to settle perfectly. Generating these precise ultrasonic waves is often done by combining fields. Engineers run electrical currents through specialized piezoelectric crystals, converting that electrical energy directly into extreme mechanical oscillation. By systematically scaling frequency and tuning for resonance, engineers can overcome physical constraints at any scale with minimal energy input. In traditional engineering, vibration is viewed as an inherent system failure, a flaw that needs to be minimized or engineered out entirely. We have to change how we see this. Instead of fighting physical resistance with continuous force, we use frequency to bypass friction and reduce the physical effort required to move materials. You're now fully equipped with the 3-step Idea Mechanics framework. Identify the friction, introduce rapid oscillation, and elevate to resonance. Look closely at your own industry. Where are your peers wasting time and energy relying on continuous static force? Where exactly is the big hammer failing? Drop a comment right now and tell me exactly how you would apply Principle 18 to solve a specific frustration in your field. Let's keep building this discipline together. I'll see you in the lab.